we consider the specificity of the liquids in the aspects of the flows and the capillary effects. So first we'll start with the flows. The flow or the liquid that delivers the flow is characterized with a viscosity and with a pressure. So because both of them characterizes the flow. So the next one, we need to have some pump to pump the liquid through the pipes. So this means that we need to consider the pulses in the human body. The pump is a heart that works in the pulse manner. So that is why the flows will consider it with the aspects of viscosity, pressure, and pulse. Let's start with the viscosity. Newton, somewhere 400 years ago, approximately a little bit less, he worked in different directions, scientific direction, and one of them, he devoted his scientific light to liquids. And until now, we use the results by Newton. For instance, this is a flow or some substrate. So now I get the liquid at this surface. So this is the liquid layer. Now I say that the coordinate x is directed from the surface of this liquid layer into the perpendicular way to the floor. Now I put some weight on the surface, connect this weight to the dynamometer to measure the force that I pull this weight over the surface of the liquid. Let's do such an experiment. Newton had delivered this experiment several times, a lot of times, and he proved that the force is equal to the area that the weight is contacting with the surface of the liquid, S. So this is the contact area, contact surface, and the proportionality coefficient, he said that this is a dynamic viscosity, and dv dx is a gradient of the velocity. For instance, here, this liquid layer follows this weight, and the velocity is the highest. And here, the velocity is the lowest. Actually, the last layer, the last molecular layer, doesn't have any movement. So the velocity here is equal to 0. And here the velocity is the maximum, has a maximum value. So he proved just from the experimental, by the experimental way, this formula. It's a very easy formula. And he said that this is the force of friction. Really, this is the force, this force that is applied here, is the force of the friction in between this layer and this layer of liquid. Everything is fine, except of the gradient. Have a look. In this direction, dv is negative because from maximum to 0. But x is a positive from 0 to the maximum value. That is why the gradient is a negative. Is this clear? The gradient has a negative value. Is this clear?
Yeah.
If so, the friction force must be directed in this direction. But from the experiment, he pulled in this direction. So that is why there is a contradiction in between this gradient, negative value, and the force is directed in this direction, and the force that has the positive value. To avoid this contradiction, he said we need to write here minus. This is only the reason that the minus is written here. So finally, we have the force, the friction force by Newton, like this one. The question, please. Hello? Very scattered.
Yeah.
Okay. From this formula, it is very easy to get the viscosity coefficient. Just to measure the force and to measure the gradient and know the contact surface, the area of the contact surface, nothing else. So he worked with the liquids, and he didn't find that the viscosity coefficient depends on the velocity of this load that he worked the experiment. However, the Newton followers repeated his experiment several times, a lot of times, with different liquids, and they have found that for some liquids, the viscosity coefficient does depend on the velocity. That is why when the viscosity coefficient doesn't depend on velocity, these liquids are named as the Newton liquids. And the liquids, when the viscosity coefficient does depend on the velocity, are named non-Newton liquids. Now let's go to understand what is the reason that the viscosity coefficient can depend on the velocity. So this is a model of the liquids that Newton worked with. These are the liquid molecules. They are like the solid balls. And he selected the liquids, I don't know, occasionally, or maybe he had some ideas to work with these liquids. If these balls are solid, very strong, very hard, because of the movement of the molecular layer against each other, like this one, the balls doesn't have any interactions. The balls doesn't have any deformations. So the other story for the non-Newton liquid, the liquids are the molecular structure. For instance, the long molecular, two different layers, and they are connected in between cells. And now, because of the motions, there is a deformation. The molecules are deformed, then are conformed, then change the conformation, the design, means the bonds. In this case, definitely the velocity is a factor that influences this deformation. Is this clear? Hello? Hello?
Yes,
Yeah.
it's clear.
So this means that the liquids that have long molecules, we are saying molecular liquids, they are not Newton liquids, they are non-Newton liquids. And the viscosity coefficient of these liquids depends on the velocity that we are making the experiment. However, this connection depends on the molecular design. Different molecular delivers different connection in between the viscosity coefficient and the velocity. Is this clear?
Yeah.
So this is the reason that we can apply the viscosity coefficient as a parameter that characterizes the molecular structure of the liquid. Now, for instance, we have the patients with known any pathologies, and we measure the viscosity coefficient in dependence on the velocity for these liquids of the patient. And now we compare these viscosity coefficient regularities on V with the patients that have some diseases. And we see that the regulations N to eta to V are different for the normal, healthy patient and the patient with a disease, because the molecular structure of the liquids of the non-healthy patient differs on the healthy patient molecular liquid structure. Is this clear?
Yes.
This is the reason that we apply the viscosity coefficient eta as the index of the human liquid quality. In particular, if you are dealing with a protein-like liquid, blood, the typical liquid that has a lot of protein, we can say if the viscosity coefficient is different or shifted, so this is the index of some disease. Which one? So this is the other story, but this is the index. So the next story, how to measure the viscosity coefficient, and we speak about this next time. Maybe you have some questions.
Ne jautājums par šo tēmu, bet tad
Jā.
nākamreiz mēs rakstam vienkārši visu lielo mehānikas teorijas
Yeah,
darbu.
visu mehāniku, yeah, so next time you have the test on the entire mechanics. That's true. So be prepared. So, some more questions? Vēl jautājumi, lūdzu. Alo.
Nē, nav. Paldies.
Okay, so see you next time.
Visu labu.
Paldies, visu labu!
Paldies, visu labu.
Jā, paldies jums, ka
Thank you.
izturējāt.